that is parallel to the transmission axis will go through. The others will be cut off. Okay, that's the polarizer. It polarizes the light. If you start with unpolarized, you'll get a polarized light. Okay, how will you check the type of polarization of a light beam? So think about that. If you have one direction and if you take a polarizer, okay, and you rotate it in front of the beam, when the transmission axis is parallel to the direction of polarization, then you'll get all the light coming through. But when the transmission axis is at an angle, you only get a component. So the light intensity will reduce. Okay, so that's how you will check. How will you change? Those are all the things. They should be in the video. If you see the video, it'll answer most of these questions. How will you change the direction of polarization and so on? So here is the set of instructions. So 2.2 will be the experiments that you will perform. What is the direction of polarization of your light source? How will you determine? You've answered that in your pre-lab. You'll come here with this answer and the video together. You will be able to do all these experiments. So that is the first experiment, which you can finish in one class, and you can also get started on the scattering of light experiment. So all that we will talk about in the beginning of the second, Thursday. We'll again talk about the experiments that you will do and then what you will do for the next time, okay? So for example, I've shown here, as I said, everything is within this unpolarized light. Do you see this arrow here? Do you see the three, it's not the three directions, it is only the electric field and the electric field. The electric field is in this direction as well as this direction. And this is the direction of propagation, this long arrow, okay? So this unpolarized sunlight, which means that we are showing only the direction of the electric field, which can be here along this vertical as well as horizontal, okay? As I said, you can also show many lines like this. Sometimes they show, I don't know if I have that. Okay, but instead of showing all the thousands of directions like this, you show these two, which means the light, if it's like this, it has component Y as well as X. If it is some other direction like this, it is again X and Y. That's what it shows. If you just draw two perpendicular lines, it's enough, okay? So here, for example, linearly polarized light, you have only one direction, okay? So it's in that figure. Okay, so let's see.
Dr. Lahat.
Yes, yes.
So which of those experiments will we be doing in person on Thursday?
Polarization experiment.
Okay, that's 3.0.
No, not 3.2.
Oh, 2.21.
Yeah, let me get back to the, okay, let's look at this. Okay, so this one, right? This is what we were looking at. So you will be doing, you would have completed 2.1 and by then, so you'll be doing 2.2 and we will start with 3.0. Okay. All right. Let me see.
So do 2.1 and 2.2 on our own at home, and then because 2.2 says record observations, I'm assuming that's from the video.
Yeah, I think this one that I have is a little older version of the thing, but what you should have is the current version of the instructions.
Oh,
yeah. I don't know whether the numbers are the same. What do you have it with you? Does anyone have the instructions?
Yeah, it's open.
Yeah, 2.2. Let me check. I have it open.
Looks.
It looks the same. Yeah. Yeah, it is the same.
Okay. Yeah. Yes, so you will do the first one, and then first one in the sense you go according to that what's called experiment 1. Okay, experiment 1, that's what you will do, which is 2.0. Okay, and then actually the actual in-class part will be 2.2. Okay, 2.0 is the 2.1 is pre-lab, 2.2 is the in-class part of the experiment. Then we will also, you can also start the light scattering, but you need to watch the video also for that. And then you can finish light scattering and the Brewster angle, which is the which is this one, measurement of Brewster angle. You can finish that in one day actually, because these are mostly observations. You're not doing any numerical calculation for this. Okay. All right. So I think that's all I have.
So when we come in on Thursday, we can do the experiment parts of 2, 3, and 4 if we do all of the labs.
Yeah, if you do all 3 labs, then then it's okay. You don't have to come back, but you cannot stay beyond 4:45. They
Okay.
have strict guidelines about
Okay.
that. I even thought at one time, why not bring them one day and do all the experiments? But they said, no, it has to be synchronous. They cannot come more than only at the time of the class. And then I have to take attendance. Okay. So that's also a requirement. Even otherwise, I would take attendance because you are expected to be in class. I mean, expected to do the experiments. Okay. So that's what we will do. And let's see, there's another chat. Let's see.
Where do we show up? Like, do we just wait for you in front of Live Oak or Eucalyptus?
Oh, and sorry, you will come to LO 1100.
What's the earliest we can show up for the meetings?
2 o'clock.
Okay.
Because that's when I'll begin. I'm not, we won't be repeating everything. You will notice that I am there in the class all the time. And I don't know if you talk to anyone, I'm very busy in the class. I keep looking at everything that everyone does. Okay, I have designed these experiments to convey physical concepts. I have given importance to understanding the basic physics, okay, that are involved in optics. And I'm giving importance to the writing. Why writing is important? Writing is not just conveying to somebody else, oh, I have to. It's not that. You're actually talking to yourself. You're explaining, you're teaching yourself. Remember that writing is very, very essential. Not because the world is set up that way, I have to explain. No, for you yourself, it's important to write. Okay, for yourself, because when you write, you focus, you organize your head and thoughts. It's not the same by just talking, oh, I understand this, I understand this. When you start writing, you will realize that you don't really understand many things. And then you think it over because you have to put it down in a logical sequence. And that becomes, there's a lot of accountability when you write to yourself. So you're not doing this for me. It's a learning exercise. If it were for me, I would say, why would I want anyone to do anything for me? Because who wants to grade? So, but it's my responsibility as your instructor that you go out, you learn something. So if it were for me, as I would say, then I'll say, done, go, bye. You've done, I've seen you in class, you get an A, go away. No. So that's not the way it works for me. Okay. So that's why we write. We write because only then we understand. Okay. And teaching also, when you teach, I don't know any of you are doing a TA work or, what's that called? Peer learning facilitator, something like that, helping students with homework, other school students or anything. Take on such jobs is very, very good. So because you will learn a lot when teaching. Okay, so that's why I want to give importance to writing. doing experiments is very important, but because of this COVID semester, they kept telling us, oh, you have to be ready. You can shut down anytime. So if you shut down, then what? So I said, okay, in that case, they can still do something at home, which will illustrate many physics principles. Okay, remember, that's what I'm going for. Okay, that you understand the physics. So that so it's very important that you watch the video, because in class there is no explanation of anything. In class it's mostly about the hands-on work that you're doing. Okay, so how do I put this? How can I raise the height? Go pick up a notebook, raise the height. You will see that all these experiments are are just we don't have any fancy stands and things like that. You have books and things like that to put your stuff to raise the height. In optics, one of the very important thing is alignment of light. It has to go through this hole. It has to, that's a very difficult thing. So all those things we are doing just with the help of props. So that's so when you're doing, put that as your priority. That am I understanding the underlying physics? Okay, so you will be learning about dipole radiation and so on. Already you now have some idea that I mentioned the E and H are perpendicular. I mentioned for you E cross H. It's very important that you understand what's the Poynting vector. Poynting vector is E cross H, and average of the Poynting vector is the amount of energy, electromagnetic energy or power. Power is energy per unit area per unit time. That's the Poynting vector. Magnitude of the Poynting vector. It's the average of E cross H. What's the meaning of intensity of light? Half of epsilon 0 E0 squared, where E is the electric field amplitude. Those kind of things, they are very basic points. So if somebody asks you what's the meaning of electromagnetic energy, say E cross H, average of E cross H. Okay. So you should be able to calculate what is E cross H. If E is along X and H is along Y, then X cross Y is Z. So that's the direction of propagation of light. And when you do E cross H and take the average, it'll come out to be 1/2 epsilon 0 E0 squared. Okay. So that's the amount of electromagnetic energy present in a wave. Okay. And when you want to compare this to the photonic nature of light, you'll say, okay, this is it's like harmonic oscillator. What is harmonic oscillator energy? If you have an oscillator, so harmonic oscillator problem is a very fundamental problem, and we do that because it applies to everything. Okay, you take a spring and a mass, and then you say that who cares about a silly spring and a mass? But then you realize that that's just a paradigm. What's the energy of a harmonic oscillator? If it's oscillating, yeah.
1/2 m omega squared, I believe.
1/2 Ka squared, yeah. Omega is square root of K over M, and yeah. Okay, M omega squared if you want to give in terms of frequency. Okay, if you want to talk in terms of the oscillator properties, it's 1/2 K, where K is a spring constant and A is the amplitude, A squared. Do you see the same form in electromagnetic energy also? It's 1/2 epsilon 0, that's like the K, and A is the amplitude squared in harmonic oscillator. Here it is E0 squared, where E0 is electric field amplitude. So a wave is a harmonic oscillation that is traveling. Okay, so that's why the energy form is similar. Any harmonic oscillation, the energy is 1/2 some constant of that thing, of the oscillator, amplitude squared. Okay, so these are the kind of points I want to bring out, and this will be like you're doing an experiment and you're understanding this basic thing. Okay. All right, so I need to let you go so that you can start working on your pre-lab. And please do watch that video, and so that you're ready to start as soon as you arrive.
If we have questions, we can email you. If we have questions, we can email you.
Yeah. And remember to fill that health survey before coming. Have you been, I know, I believe that Dr. Chowdhury required that you attend only once in the entire, okay. So in that case, you had to do the health survey only for that date. But here you'll have to do, well, 4 times because you'll be coming in a total of 4 times. Okay. All right.
Wait, one more question. So you said that Tuesday's group only meets on Tuesday, so we only go to Zoom meetings on Tuesday?
No, everybody goes to Zoom meetings every Tuesday and every Thursday. So you will begin Thursday with the Zoom meeting. The Thursday group will also attend the first few minutes, attend the Zoom meeting, which I believe will only be a few minutes. Okay.
Okay. One more
Yeah.
thing. On Thursday I have my test, but I also have like the dress, so I get like 2 hours double time on it.
I
But
have the same thing as well.
but my class like well, with the double time and everything, it's gonna be it's going to go like, because my class originally ends at 1:45, but with the double time and everything, then it's gonna extend it. But is it okay if I'm excused, or do I like
Oh, you have you're saying you have a test on Thursday,
yes.
and that there's something funny about the test in the sense that double time means you have more time allotted than is that what the instructor is doing?
Yes.
Oh, okay. So the instructor says you can go beyond 1:45.
Yes.
So you cannot. What about the students that are coming in on Thursday at 2? What will they do?
Well, wait, what do you mean?
You are all in the same class, I assume.
Oh yes, but since I'm under like I have dress, then I'm allotted like
Okay.
yes.
Also, not everyone. She's talking about 389, which I'm in as well.
Okay.
Some people already took that, or most people already took that. We're in it right now, me and Araceli. And I don't have double time, but I have time and a half, so I get like 30 extra minutes.
Okay.
But yeah, but the class normally ends at 1:45, so normally we have 15 minutes in between. But because of the extra time, it's through DRES, the Disability Resources.
Yeah. Okay. So, but then again, the same thing. If the test ends at 1:45, and those of you that are taking the test somewhere else or on campus, or how is that going to be? Then will you be able to make it to class at 2? The 4 of Raymond, Linda, Miguel, and Nadia.
We don't have that class.
We don't have that class, yeah. So
Good.
we will be able to make it.
So we'll be able to make it work.
All right. So I'll see you all on Thursday, and Araceli, you will be excused because you have a real reason. Okay?
Okay, thank you.
Okay. All right. Okay, get to work.
Okay. All right. We'll see you.
See ya. Thank you.
Bye.
Bye.
Thank you, Professor.
Sure.